This data represents the values taken of exposure from a radiation source at different distances, measured in centimeter, and the exposure is measured in milliröntgen per hour. Generally, the detector gives the dose value. Personal dosimeter gives us the dose value in microsievert per hour. These are the units to describe radiation doses in air to the human body. So I plot exposure. We have the relationship for exposure rate. Exposure rate is equal to the gamma constant, capital gamma constant times A, the activity of the source, and upon R squared, which means it's an inverse square relationship. So let's develop that from this data. So I copied the data of R detectors, and on Excel sheet, this one, in column B, I am pasting the values. Okay, very small one. And now from the last column, with the title, so the values have been pasted. Okay, it's barely visible. Now the first attempt is to plot the data. So I reserve a frame. I select the XY scatter. So scatter type plot, there are other plot options which are useful in their corresponding applications. So far only the frame has been generated because no data was selected. You can make the selection of data, add a series. So you can give the series a name. Since this is only one plot, therefore you can omit this one for the time being. So from 20 centimeters to 90 centimeters, with a step of 5 centimeter, the experiment was performed to observe the exposure rate. Well, exposure and dose are convertible with a constant. So here we are. Okay, only one point has been plotted. So I do the removal of the series. Something has created the error. So again, carefully, I select the X values. X values. And for Y values, the exposure values. So we have got several points. So it seems to be decreasing exponentially. So if we are interested in looking for a relationship from this one, this is not a straight line. So polynomial is not that fine. So the strategy is to first change the vertical scale, one scale change, right? So I do the formatting of this axis. The option is available, and here is the option. logarithmic scale. There is another option that you can plot the values in reverse order. So there are several options to play with the graphs. Now, this graph is a semi-log graph. So a semi-log plot. Vertical scale is logarithmic. And if the vertical scale is logarithmic and you assume that your data fits to a straight line on the semi-log paper, then the relationship you have to consider of type y equal a e raised to the power bx. Right? So if I assume that this is the required line, a straight line fits here, then the equation behind this one, not the symbol, okay, equation can be inserted here. Yeah, right. So to complete my demonstration, okay, so at this point, the equation behind this one is something like y equals a constant a and e raised to the power bx. Right? If a line falls on a straight line on a semi-log paper, if the data conforms to a straight line on a semi-log paper, it means the model behind this one is y equals a e raised to the power bx, right? This can also be confirmed if you plot only the vertical axis as logarithmic, vertical variable, take the log of the vertical variable and plot it against the x. This is possible. But in this problem, we are rather interested to look for a power relationship. So now I change the other graph also to the logarithmic. And let's see. So if the straight line from these data points is more favorable to you from visual inspection for the time being, actually to come up with the equation, you must learn the regression analysis, right? Fitting a curve to the experimental data points uh, to the most suited equation is the regression analysis. So if this is the situation, if this is the situation that you get a straight line on the log scale, right? I have not changed the data values. Now it means the equation from my knowledge, I can say the equation now is a x raised to the power on log scale. This is something that I know from my knowledge. But this can also be confirmed with another strategy. And the other strategy is instead of changing the scale of the graph, right, change the values of the data points. So now let me do that in another sheet. So the same data x, and I here not this one. I wish to copy the data. Okay, that's fine. That's fine. And now let's get the equivalent representation. So I take here I give a label log of R and log of the exposure value. So in Microsoft Excel, ln function is for computing the natural log. It's done. And similarly, for log of exposure, I write log of the exposure value, and the same should be repeated. Same should be repeated for the rest of the values. And now I plot x and y in terms of the log of r and log of x. So again, I insert a scatter plot. Select the data values, add a series. On x-axis, I will take the meanwhile something strange has happened to my computer. Okay, so this one and the all the values, and for y-axis so we have got the equivalent representation. A graph without labels is not a good thing. So whenever you make a plot, you must provide what is on x-axis and what is on y-axis. These are known as axis labels. So it's a straight line. It's a straight line on the linear scale. For this one, you can do the regression line. You can get the regression line by adding a trend line here. And now the linear line should be selected. And let's request Microsoft Excel to display the equation. This is basically the regression analysis, right? You should learn that because the concepts are involved when you extend the problem in higher dimensions. So learning just making a click is not a representative of knowledge, and there is no knowledge in just doing the clicking. So please do learn something beyond clicking. So here the slope value in this line is -2, right? Is -2. And if you do the comparison, you will find that it is the exponent of the original variable, original x variable, right? So that part can be extracted. So in the log scale, uh, only we plotted the data values and we got a straight line. So if we consider that should be the model for our problem, so the equation in that case would be y equal to a x raised to the power b. And the slope you got here, -2.1, this is basically consistent with the value of this b variable, this b. So therefore, there is nothing like slope on the log scale. It is basically the slope when you transform the data and get the slope from the linear scale.